Okay, so this time our topic is all about case studies of web system development presented by Sir Jason. Okay, using the UML2 web synthesis tool, and this lecture or this topic shows how to build a complete online property search system. So a web system's automated construction of a GSP-based architecture is also demonstrated. So the UML2 web tool generates three types of components. So Java classes that generates web pages as HTML text for the application interface. Of course, Java servlets that receive requests from these web pages and process them, returning either an error page or the next page in the system's interaction sequence, and a database interface that is used by the servlets to update and query the data tables of the database. So using the UML2 web tool, this item shows two simple examples of developing web applications from abstract unified modeling language or the UML models. Other variation on this approach, such as the creation of the G2EE components and interfaces, are feasible. So, okay, to give us more detail, let us all welcome our presenter, Sir Mark Jason Zizon. Go ahead, sir.
Good day everyone, I'm Mark Jason Zizon, and today in this chapter we present a complete development of the online property search system. Using the UML2 web synthesis tool, we will also illustrate the automated generation of a JSP-based architecture for a web system. But first, let's have a look at the start screen of the tool that we will be using. It's called UML-RSDS, and it's free to download at the following link. UML-RSDS or Agile UML provides rapid automated construction of software systems from a high-level UML specification, class diagram, use case, state machine, and activities. The tools are currently free to download and use. In general, standard UML2 and OCL is used for specification and design. The tool can be used as a part of software development to reduce coding costs, time, and errors, and to ensure a greater consistency between system components written in multiple languages. It can ensure the correct and consistent implementation of business data and logic in multiple system components. Also in this chapter, we will discuss the following topics. First, property system specification. Second, web system generation. Third, interface component. Fourth, servlets. Number 5, database. And the number 6, GSP architecture example, cat database. So let's proceed. For the first topic, we will discuss what is a system specification. A system specification describes the operational and performance requirements of a system, such as a computer and a computer system. It is a considered high-level document that dictates global functions. System specifications help to define the operational and performance guidelines for a system. It may outline how the system is expected to be worked and what may be not include. Key specifications may include interface definitions, document design rules, and functional areas. For figure 10.1, we can see the use case diagram of property search system. The platform independent module use case diagram of the property search system that we will synthesize code for are shown in the following figure. We need to specify the operations that a user of the web system will be able to carry out. These are based on the use case of the figures. First, create user. It defines a new user and add it to the system. Next, get user matches. It lists all the properties that match given user requirements. Third, Create property. It defines a new property and add it to the system. Number 4. List user. It lists all the user in the system. Number 5. List property. It lists all the properties in the system. Also, for the system, we have two constraints. The first one is a user minimum price must be at least 0 and less than or equal to their maximum price choice as a class invariant of the user. The second one is a property matches a user's requirement if its price is in their range, it is available, has at least as many bedrooms as they require, and is of the same type and in the same area as required. This defines the implicit association user property. The platform-independent module class diagram is shown in Figure 10.2. In addition to the use case diagram and constraints, we also need to specify the class diagram. Before a web system can be generated, the data model needs to be refined. Primary key needs to be introduced for all entities to be persistently represented in the data repository of the system. Explicit many associations need to be replaced by many associations. And last, foreign key needs to be introduced in place of explicit many one association. The following figure shows the refined model in this case, the user property association is implicit, so no further refinement other than providing primary key for the entities is needed. For the second chapter, there are three kinds of components that are generated by the UML2Web tool. First, we have the Java classes. Second, Java servlets. The third one is the database interface. Let's discuss the Java classes first. Java classes which generate web pages as HTML text for the interface of the application. The second, Java servlets, which receive requests from these web pages and process them, returning either an error if some error has occurred in the input data or in processing, or the next page in the interaction sequence of the system. Number 3, a database interface, which is used by the servlet to update and query the data tables of the application. Next is Figure 10.4 shows the interaction sequence of the property search system. It shows how each page interact with one another and what will be the next page that it will display. For the next figure, Figure 10.5, it shows the hierarchy of a web page generation classes for the property search application. Figure 10.6 shows the supplier-client dependencies between the property system components. For the third topic, we have the interface component. So let's discuss what an interface component is. A component can be a user interface component or a non-user interface component. Java server faces UI components are configurable, reusable elements that are composed of the user interface of a Java server basis application. A component can be simple, such as button, or can be a compound such as table composed of multiple components. Java Server Faces technology provides a set of user interface component classes and associated behavioral interfaces that specify all the UI components functionality, such as holding component state, maintaining a reference to object and driving event handling, and rendering for a set of standard components. The component classes are complete extendable, allowing component writers to create their own custom components. The following code shows the base page of the system is defined by the class. The next, the code can be modified as required to construct a common background, image, or color for all the web pages of the system. This adds a footer with a link back to the command page and set the background color of all pages to yellow. The base page class is extended and specialized to produce all the web pages used in the system. We can also see the different interface component. We have the command.html. It was created by the command page. Create user.html. It was created by the create user page. Create property.html. Created by the create property page. We have the list user.html. Created by the list user page, and its result displayed by user result page. We have the list property.html created by list property page, and its result displayed the property result page. And last, get user matches.html, which was created by the get user page, user matches page, and its result displayed by the property results page. We can see the command page here, the command page class. The command page is created by the class command page extend this page. The code here will output this following web page. We have the create user, create property, list user, list property, get user matches. Next, we have the create user page. The page for registering new user is generated by the class create user page extend base page. It's still a continuation of the code, and it will display the following form. We have the user create user form here, user ID, username, user email, user minimum price, user maximum price, user area, user type, user bedroom, and a create button. We have the create property page. This class, the class for generating the create property web page is very similar for the to that user. It's just a continuation of the code. Next interface component is list user page. The web pages for listing all rows of database tables simply consists of a command button. Here we can see that the method used is post. Get could be used instead of post here to allow browser to cache the result of the query for later redisplay in the same browsing session. So we can also use the get method here instead of post. Next, we have the next interface component, user result page. The result of this command are displayed using the user result page class, which generate an HTML table from the rows in a given result set. This next interface component is getUserMatch page. The form for finding all matches of a given user containing a field for entering the ID. Again, here they use post. However, we can still use get method. For the fourth topic, we have servlets. So first, let's define what a servlet is. As per Oracle documentation, servlet is a Java programming language class that is used to extend the capabilities of the server. A servlet is a Java programming language class that is used to extend the capabilities of a server that hosts application accessed by means of request-response programming model. Although servlets can respond to any type of request, they are commonly used to extend the application hosted by the web server. For such application, Java servlets technology define the HTTP specific servlet classes. We have the following servlets: public class command servlet extend HTTP servlet. For each input web page, there is a servlet which responds to a request from that page. In the case of the command.html page, the servlet simply returns the input web page of the requested command. Next, we have the command servlet extend HTTP servlet. The servlet for the create user operation is shown here. Hard-coded web pages could be used instead of dynamically generated pages. However, for more complex systems, dynamic pages are more flexible. For example, the possible categories of properties could be listed in a database table, so that create property page and the create user page could look up the same current category and always generate HTML form with the correct list of options for the property type attributes. We have the following servlet. This servlet checks type of constraint that the ID, price, and number of bedroom values entered are integers, and the logical invariance of the user class, that the user minimum price is greater than or equal to 0. Also, that the user max price is greater than or equal to the user minimum price. If any of these constraints fail to be true, then a message is added to the error page, and the error page is returned to the client browser. The error page is created by the class. So we have the following servlets here, following codes. This servlet created for creating properties is similar. Data is only added to the database if there has been no error, in which case the command page is returned to the client. Next is, we have the following code. The servlet for listing all users and property have no input parameter for the request they handle, but it execute a select asterisk query on the relevant database table and present the result using a result page. Next, the servlet for obtaining all matching properties that meet a user requirements. Here's the code for that. Also, Figure 10.9 shows the result of the list property. Property result page is used to list all the matching properties found. Figure 10.9 shows the result of selecting the list property command. Next, we have figure 10.10, the result of get user matches. Figure 10.10 shows the result of selecting the get matches command for a user who wants 2-bedroom Fiats under in the central area. For the fifth topic, we have database. So let's define what a database is. A database is an organized collection of structured information or data typically stored electronically in a computer system. As per oracle.com.ph, a database is an organized collection of structured information or data typically stored electronically in a computer system. A database is controlled by a database management system, DBMS. Together, the data and the DBMS alongside with the applications that are associated with them are referred to as database system, often shortened to just database. The data repository of the system consists of a database and a database interface class in which the queries required by the property search application are defined as SQL prepared statement. So here we have the following code. Then still continuation of the code. Here's still a continuation of the code. For this, select asterisk may not return the field of the table in order they are defined in the table. It is more portable to name all the fields of the table directly, and UML to Web has an option for generating this version of prepared SQL statements. To specify a particular database, we set the drivers and the database name variable as required. Here. Next, for this code, we can also use PostgreSQL. For the first code, they use SQL. For this code, they use PostgreSQL. For this code, the second one, to create the property system table, the PSQL interactive database program is used. They use Postgres here instead of SQL. For this code, the statement creates an empty property table with the specified columns. Here, it just defines the property ID, the property price, the property type, the property area, the property available, property bedrooms. For the last topic, we have the JSP architecture. The JSP architecture is a three-tier architecture where each part has its own roles and functionalities. The web server needs a JSP engine, a container, to process JSP pages. The JSP container is liable for intercepting requests for JSP pages. We can use Apache, which has a built-in JSP container, to support JSP page development. A JSP container works with an online server to supply the services a JSP needs. and the runtime environment also. It knows the way to understand the special elements that are part of JSPs. For this, we have the JSP architecture example, a cat database. This example illustrates the generation of web architecture based on a JSP, Java Server Pages, instead of servlets, and provide another example of how class environments are encoded as constraint checking code in the generated web system. The specification class diagram is shown in figure 10.11. The system record information on cats. Example, as insured by a pet insurance company, and maintain a business rule that if a cat is under 5 years old, here, its monthly insurance is £5. The first one. The second one, if the cat, otherwise a fee is £8 here. Next, we have the use cases are to create a new cat and to list all cats. Here. Figure 10.2 design class diagram of the cat record system. It adds an integer cat ID. Integer identify attributes to the cat entity. So we have the following entity: age, fee. Next is figure 10.13 shows the state chart of the system with error pages omitted. So here, it shows figure 10.3 shows the interaction state chart of a cat record system. We have the create cat.html, command.html, cat result HTML, then list cat.html. Next, we have the architecture of a cat record system. The architecture of the generated web system is shown in figure 10.14. The HTML files create cat.html and list cat.html. Here and here the other one. It gives input form for this operation and invokes corresponding JSPs, create cat.jsp here and list cat.jsp. The file command HTML is included in each JSP to provide a navigation to the command option. Create cat.jsp copies the form data to the cat bin. Here, a stateful session bin, check if the data was correct. Using the isCreate cat error method display any errors. If there are no errors, it updates the database via the bins. Next, list cat.jsp obtain the current list of cats objects from the bin and format them in a table. This is the code for that. Next, we have the cat bin. The cat bin perform a type and invariant checking of the attributes and interfaces to the database to update and query the database table for the cat. Here, you can see the code here. Another sample of code here. And here's another code. In this case, the bin only checks that the invariants are true before permitting an update. However, a more proactive approach which enforces a change in fee, if a change in age occurs, could also be adapted. Here. The business tier is the correct place for such business rule related code and the components such as J2EE. Entity bins may be necessary to ensure that such invariant maintenance code is carried out in a transactional manner. We have the class CatVO. CatVO is a value object for the cat entity and is simply used to transfer data between the presentation and business tier to avoid exposing classes such as the result set to the presentation tier. That's end my presentation. Thank you for listening and have a good day.
Okay, so I just want to reiterate some key points in the discussion. So a while ago he mentioned about the hard-coded web pages So the static web pages could be used instead of dynamically generated pages. However, dynamic pages are more versatile for more sophisticated system. Let's say, for example, possible property categories may be included in a database table such that create property page and create user page could search up current web system development case studies. Create HTML forms with a correct list of possibilities for the property type attribute in all categories. Our presenter also mentioned if there are no errors, data is just added to the database and the command page is returned to the client. When it comes to database, so the system's data repository consists of a database and the database interface class is which the property search application queries are described as SQL prepared statement. When it comes to select asterisk, it may or may not return the table fields in the order in which they are defined in the table. It's more portable to name all of the table's fields directly. And the UML2 web can generate prepared SQL statement in this format. And we set the driver and database name to identify a specifying database as needed variables. So when it comes to bin, in this scenario, the bin just verifies that the invariants are valid before allowing an update. But a more proactive method such as enforcing a fee change if the age of the user changes might also be used. So such business rules related code belongs at the business layer and components like J2EE entity bins may be required to ensure that such invariant maintenance code is executed in a transactional way. And to summarize, using the UML2 web tool, give two simple examples of developing web system from abstract UML models and other variation on this approach, such as the creation of J2E components and interfaces are feasible. And that's it for this topic.